All right, guys, this is Advanced Math, Unit 6, Morning Review. We are ready to get started. First one, we've talked about our tangent functions. Is this tangent flipped on the fraction, yes or no? So it's not cotangent. Is it flipped on the negative, yes or no? Yes. So it's negative tangent a plus b, so 40 plus 10. Negative tangent of what? Is 50 a special angle on our unit circle? No. It is not. That's our answer. Okay. Next one. As tempting as it is to say that looks a lot like that one but flipped on the negative, why is it not this one? Because of the 2. There's no 2 there. Is this a double angle or one of the old Pythagorean identities? Does it equal cosine squared or negative cosine squared? Negative cosine squared. No doubling the angles, just negative cosine squared. Next one. Okay, I've done this one with you in notes, and I made a big stink about it. I talked to you guys about it the next day in class. I just did it with you guys right now in the morning on the practice test. Do you think it's going to be on the test?
No.
Do you think a lot of kids miss it on the test?
Yeah.
Now, I said it during the practice test. What's the mistake kids make? Expand, expand, and FOIL. Expand, expand, and FOIL. Should we be doing that? Sine and cosine, sine and cosine. There's these two are the same, and these two are the same. What are we going to do? Condense to sine or cosine? It's a plus sign, so technically, does it matter which one's A and which one's B? No, but to be on the safe side, what is A? Theta plus 40. What is B? 20 minus theta. So sine of theta plus 40 plus 20 minus theta, sine of what? 60. Because those there cross out. And is sine of 60 a special angle? Or 60 a special angle? What is sine of 60? Root 3 over, it's okay, root 3 over 2. Yes or no?
Yes.
What about the next one? Did we see that on our practice test as well?
Yep.
What did you guys tell me to do on that one? Pull out. Okay, I heard, I think in the practice test I pulled out the negative, so this one I'm just going to pull out the 4 and see. 1 minus 2 sine squared 15. Covering the 4. Is this a double angle or is this Pythagorean's identity? Because of the 2. And is it in the right order? So I don't have to worry about any negative. It's just going to become cosine of double the angle. But what's in the front that I can't forget? 4 times cosine of double the 15. The angle theta is 15 degrees, so I end up with cosine of, or 4 cosine of 30. And 4 times cosine of 30, what's cosine of 30? Root 3 over 2. Did I hear a question? Okay. 4 root 3 over 2, or you reduce first. Either way, cross reduce or multiply and then reduce. What do you end up with? 2 root 3. Questions? Okay, 5. We saw all of these we just did. What do we do when we see this one on the test? And don't say skip it.
45.
Right. So sine of 45 plus what? 210. And then we expand. Sine of 45 cosine of 210 plus sine of 210 cosine 45. Sine of 45 is 1 over root 2. What's cosine of 210? I'll give you a hint, it is negative. Negative root 3 over 2. Plus sine of 210 is also negative 1/2. And then cosine 45 is 1 over root 2. That gives me, oh, I'm running out of room. That gives me negative root 3 over 2 root 2 minus 1 over 2 root 2. Do you guys agree? Or you could write that as plus negative 1 over 2 root 2. That's perfectly fine. Any questions on how I went from here to here? So final answer, since they're common denominators, is negative root 3 minus 1 over 2 root 2. If you want, you can rationalize. Is it necessary? It's up to you. Okay. Next one, what do you notice with number 6? Is it, okay, now it's friendly, so it's sine. It's a minus sign, so does that matter which one's A and which one's B? Yes, which one's A? Which one's B? All right, can you guys tell me how you knew that? Because the sign 25 should be first, right? It's always your first sign. Sign of negative what? Okay. Choice on how you do this. Which quadrant is 45 degrees in? Which quadrant is negative 45 degrees in? 4. So what is sine of 45 degrees in quadrant 4? Negative 1 over root 2. What's another way you can do it? What does sine do with the negative? Absorbs or kicks it to the front? Would I end up with the same answer? Sine of 45 is positive 1 over root 2. Take the opposite of that, negative 1 over root 2. So it's up to you and how your brain processes the problem. Either way, we end up with the same answer. Questions? Okay, next one we've talked about this one a few times. Is this one flipped on the negative, flipped on the fraction, or both? Flipped on the fraction. Did it flip on the negative? No. So opposite or reciprocal? Reciprocal. So cotangent of A plus B, or double the angle? Double the angle. So cotangent of 80. Bless you. All right. Do we have any formula that looks like that kind of fraction? Okay, ignore the fraction piece of it. Is the bottom of it, I heard one of you say it already, is that the cosine formula? Yes? And how do you know it's cosine and not sine? Yes. Because the two cosines are together, and you guys said it's a jerk because it's snobby. Yes? So cosine of A plus B, if it's adding, does it matter which one's A or B? No. If it's subtracting, does it matter with cosine? No. Not with cosine. With sine it does. So 1 over cosine of what? 55. Is that a special angle? Should I leave my answer as 1 over cosine 55? No. Thank you. Secant 55, and then you are done with that problem. Okay, we've done a few of these already as well. These are actually a little easier than the ones we did on the practice test. How do I expand it? Sine of what? And then sine or cosine of theta plus sine of theta cosine of. Which ones am I able to evaluate? The pi over 2 ones? And pi over 2 is 90, right? So what's sine of pi over 2? 1 times cosine of theta plus sine of theta times, what's cosine of pi over 2? 0. So what happens to all of this? So I'm left with just cosine theta. A lot of A's on this test? I'm feeling it, yeah. Good. Okay. I'm hoping now that we've done the practice test, does this feel kind of easy for some of you guys? Mm-hmm. It should. I mean, we spent a lot of time. What was that? Okay, good. So the morning reviews help. Good, good, good. All right. 10. We're solving. We're not proving, we're solving. Can I GCF anything? No. Can I condense it? Yes or no? Now kids, hold on. Kids will say, oh, expand and expand. This is like number 1 on your guys' quiz. It was a tangent one. And a lot of kids expanded and realized it made a mess and it was an actual condensing. Know when you're expanding, know when you're condensing. Cosine of 2x plus x equals 0. Can everybody see that it's a cosine condensing problem? Cosine of what? Okay, how many places is cosine equals 0 on the unit circle one time around? 2. What are they? Okay, and what does the 3x tell us? We are going to eventually divide by 3, but before that, how many sets are we going to have? This is the first set. This is going to be the second set, and then one more time for the third set. What do I do to the 90 and 270? 90 plus 360 is 450. 270 plus 360 is 630. And I don't think anyone grabbed calculator, so I'm just going to give them to you, and you add 360 to these two, it's 810 and 990. If you're thinking to yourself, oh my goodness, I forgot how to do those problems, then put a note to yourself, add 360. If you know what you're doing, you don't have to make the note. What do you add, or what do you divide everything by? 3. Even the original set that was smaller than 360. 30 degrees. 90 degrees, 150 degrees, 210, 270, and 330. Questions? This first set is your original set. The 2 places where cosine is 0. Cosine of 90 is 0 and cosine of 270 is 0. That's coming from your quadrantals. And then the rest of them just came from adding 360 to your original set. A total of 2 extra times, a total of 3 sets. All right, questions on 10. All right. Can I combine these two? Are they like terms? One's a 2x, the other one is not. Can I GCF it? Any suggestions? Expand this one. And lucky for us, sine 2x only has one option. What is it? 2 sine x cosine x. And then minus sine x equals 0. Because it already equals 0, can I go ahead and try to factor and use the zero product property? What kind of factoring is this? All right, what's your GCF? Sine x, 2 cosine x. Tell me where I messed up. Is it important? Is it necessary? Yes, I say it because I still have kids that are messing that up. Be careful when you're GCFing that one stays behind on this problem. Now use your zero product property. And I'll let you guys find your 4 answers really quick, and then I'll write them down. All right, what is it? When is sine 0? 0, 180. When is cosine positive 1/2? 60 and what? 300. Good job. Questions? All right, 12. What am I going to have to change here? Cosine 2x. Now, we've done a few of these. How many choices do you have for cosine 2x? How many choices do we have? 3. Now, look at the big picture. I only have a sign here and a constant there. Which one should I use? The one with both sine and cosine? The one with only cosine, or the one with only sine? The one with only sine. What does that look like? Does the 1 come first or second? The 1 comes first. So it's 1 minus what? Sine squared or 2 sine? 2 sine squared x? Do you guys agree? And then everything else stays the same. Plus 3 sine x. I'm going to go ahead and subtract the 2 over. Do I have like terms? 1 and negative 2. Any other like terms? What about these two guys?
Yeah.
No, because one's a squared, one's not. So I'm just going to put them in order. Negative 2 sine squared x plus 3 sine x minus what? 1. And because the leading coefficient's negative and I want to factor and it equals 0, I can divide everything by, leave me with what? Positive minus 3 sine x plus 1 equals 0. Have we seen anything like this before? Double bubble, and I heard substitution. Substitution it. How many of you guys factor without substitution? And I've said before, it's totally up to you. Do you guys have a preference on the method I show? Double bubble without it? This one's really nice because the only way to get 2 sine squared is with the 2 sine x and a 1 sine x. And the only way to get positive 1 is with the 1 and a 1. The only thing you have to figure out is it plus plus or is it minus minus? And the neighbor tells us it's what? Negative 1, negative 2. Is it going to give me negative 3 in the middle? All right, zero product property. Sine x equals 1/2. Sine x equals positive 1. Go ahead and find your answers. How many places is sine positive 1/2? What are they? 30 and 150. How many places sine positive 1? And that is 90. Questions? Okay. Prove. Pick a side. And I want to say we've seen this one somewhere. I think this was on worksheet 7. I know I've done it somewhere. We've done it somewhere. Pick a side, right side or left side?
Left. Middle.
Middle. There is no middle side. Left side. Right, because cosine 2 theta, if I were to expand it, there's no way I can really expand it to equal this. That's kind of a bit much. So, I heard you say it. We can do what? Somebody said it. Somebody said something about double bubble or factor. Difference of 2 squares. Sine squared theta plus what? Plus cosine squared theta, and then sine squared theta minus cosine squared theta. All right, and then what do we notice? This is a 1, leaving me with sine squared minus cosine squared. Is that a Pythagorean identity? Okay, I heard a few of you say it. I'm going to rewrite it. What was it? Sine squared minus cosine squared. So question I asked again, is it a Pythagorean identity? No, Pythagorean identity has to have a what sign right here? Plus. But do we have one for sine squared minus cosine squared? Is it exactly as it is or flipped on the negative? So instead of cosine 2 theta or cosine 2x, it's going to be negative cosine 2 theta. And does it work? All right. Questions? All right. Next page, 14, true or false? You guys already telling me the answer? Okay. I did this one with you guys earlier, but instead of 4 theta, it was a 10x. And during that time, I even said, what if it was 4x? And I did it with you guys. Do you guys remember? So I said sine of 2 times, change the 4 to what?
2.
I'm sorry, change the 4 theta to 2 theta, right? Do you guys agree that 2 times 2 theta is 4 theta? Now, is this sine of 2x? I think I wrote 2 theta on my formulas. No, I didn't. Sine of 2x, 2 sine x, cosine x. Do you guys agree? Yes? Only in our case, what is the x? It's not theta. It's not just theta. It's what? So I'm going to have the 2 in the front. Sine, instead of theta or x, what am I going to have? And cosine of, does that work? Yes or no? So any even number there would work. For example, let's put an even number. Let's call it sine of, give me an even number. 8. Sine of 8 theta would equal sine of 2 times 4 theta, which would be what? 2 sine 4 theta cosine of 4 theta. What if this number here was, say, 12? What would these numbers be here? 6 theta and 6 theta, and the 2 would still be out front. Do you guys see how that works? So true. All right, next one, true or false. Do we have any formula at all that looks like that?
No.
Does that mean it's false?
Yes.
No.
What the heck?
What the heck is right? You guys, when you have these true false, they really try to get you to think outside the box. They're not going to give you something basic and like a formula just really simply rewritten. You really have to think about it. I'm going to treat it as a proof. I'm going to pick this side. Not using our double angles, using our changing everything to sine and cosine. What is tangent? Sine 2 theta over cosine 2 theta times cosine 2 theta over 1. Did it work? What ended up happening? And does sine 2 theta equal sine 2 theta? All right, so what I'm trying to get you to recognize here, and these will be on the test, is just because it doesn't look like a formula, don't say false. It could be false, but you want to really try it because there's a chance it might be true. All right, this next one is just trying to get you, we've been talking about this since like unit 3. Put your phones away. When I have the reciprocal and it moves to the denominator, does the 2 move with it, yes or no? It is false. If I were to change this to a fraction, where would the 2 go, top or bottom? It would stay at the top, and then it would be over sine theta. We've done a few of those, like in proofs and solving and any other time. All right. This one is just recognizing your formulas. That's all it is. Do we have anything that's sine squared minus cosine squared or very close to that? Yes. What is it? Cosine squared minus sine squared? The one I gave you on the paper is flipped, so what does that mean about cosine 2x? Negative cosine 2x. And remember, that does not absorb the negative in the front. So does it work? Yes or no? Yes. All right. Letter E.
Good eye, bro.
Oh my goodness, you guys. It's your grade. All right. I'm going to cover this. Does this look like the tangent function? The tangent formula. Is it flipped on the fraction? Yes or no? Is it flipped on the negative? Yes or no?
Yes.
Yes. Do you guys agree? So if it's flipped on the negative, is it cotangent or negative tangent? Negative tangent of 30 plus 50. Is that what they gave you? So what's the answer? False. That there would have to be negative tangent of 80 in order for it to be true. Do you see that? All right. Same thing. Do not look and say, oh, it doesn't look like anything I've seen. This is like a proof. We've done these before, and this might actually be right off of worksheet 7, off the proof page. What if I'm going to treat it like a proof, which side should I pick? And change sine 2x to what? 2 sine x cosine x? Yes? And then I can't remember if it was this class or another class, but some of you guys were helping each other on what to change it to. You want to change it to, when you're changing your cosine 2x, something that's going to cross out with this 1. What would cross out with a positive 1? A negative 1. So which one here has the negative 1? This one? Okay, so 2 cosine squared x minus 1. 2 cosine squared x minus 1. 2 sine x cosine x. What happens with these 1 and negative 1? Leaving me with what? And does anything reduce? The 2's. What else? One set of the cosines, leaving us with? And what is sine x over cosine x? Did it work? Yes. If it was like tangent x equals negative tangent x, we would say false. But it worked out. It is true. And I don't know why I put false. It is true. Okay, questions? Do we want to see this last one, yes or no? Yes? Is it on the test? Every single one of these problems are on the test, and these are the ones that kids tend to struggle with. This is very similar to the one we did in the practice test. It's very similar to this one right here. Part 4, number 3. If you want to look up another one like it, Part 4, number 3. Okay. So the whole thing with the acute angles again. We draw our picture first. What 2 places is sign positive? 1 or 2, and it's not acute, so which quadrant do I cross out? So it has to be 2. Now remember, all of that is theta, and this is theta prime. You don't have to call it theta prime, it's just that's what it means about the not acute. Sine is 12 over 13, and I heard that Jason, what is it? Negative 5. And how do you know it's negative? Because it's going backwards to the left. All right, cosine 2 theta is 2. I'm going to erase that because it depends on which one you guys want to use. 2 cosine squared? Okay. 2 cosine squared theta minus 1. Will that one work nicely? Okay, 2 blank squared minus 1. What is cosine of this picture? Thank you. Negative 5 over 12. 2 times. Thank you. Thank you. Negative 5 over 13. And when I square that, what do I end up with? 25 over 169. 2 and 169 do not reduce. I'm going to write, what's 2 times 25? What is it? 50 over 169, take away 169. Why do I write it as 169 over 169? So, because it's equal to 1, and I want them to have a common. Okay, so 50 take away 169. Anybody know it? Negative 119. Good job, over 169. Please, please, please do not mess that up on the test. All right, in which quadrant is angle 2 theta? What do I have to do? We've done a ton of these. We now have to find y sine, because we already found cosine. Sine of 2 theta. What's nice about sine of 2 theta? How many choices do I have?
One.
Only one. 2, not sine of a fraction, sine of theta, cosine of theta. No fractions yet. 2, fraction, fraction. And all I care about is whether it's positive or negative. What's sine of this picture? 12 over 13. What's cosine? Positive or negative? Okay, what does that mean? Okay, I heard quadrant 3. Why is that? Because, good, cosine came out to be negative, so it's not here or here. Sine came out to be negative, so it can't be there. Does that leave quadrant 3? Q3. And then you have to explain, what would you say? Cosine 2 theta, which one did we find first? Yes, cosine of 2 theta is negative, and sine of 2 theta is negative. Therefore, it must be in Q3. Should you say anything about the acute angle? No. Questions?